In this video, we're going to go over the notes for 1.6, which is classifying polygons. So as always, we're going to start with some vocab. So a polygon, let me just turn on my pen here. Okay, so a polygon is a closed plane figure with the following properties. So first off, a closed plane figure. That means that there's no openings. So if you thought about like a mouse being inside, it couldn't get out. So it's a closed plane figure. So it's a plane and it's closed. Okay, it is formed by 3 or more line segments called sides. Okay, so poly means many, so that's why it's 3 or more line segments called sides. And each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. Now, what does that mean? So we're going to talk about some kinds of endpoints. So a vertex, for example, each endpoint, a vertex is each endpoint of a side. So right here, that's a vertex. That's also a vertex. Okay, notice how they don't double back on each other. So for example, a star is not a polygon because you have endpoints inside as well. So a star is not a polygon. Okay, but this is a polygon. These 2 figures are polygons. Now there are 2 types of polygons. So we'll just change a color here. One type is convex. So a convex polygon, no line that contains a side of the polygon contains a point in the interior. Okay, so you can't have any interior points. So let's just look at this for a second. Make this a little bit smaller. Okay, so do you see how no line that contains a side, so there are no, here's a side, here's a side, here's a side, and here's a side. None of them are inside. Okay, so if I extended them, so let's just do that. So let me just back up a little bit. So no line that contains a side of the polygon contains a point in the interior. So to make them lines, you're going to extend them. Do you see how that line does not go inside at all? That line does not go inside. This line does not go inside. And this last line does not go inside. Therefore, the pink is a convex polygon. Okay, let's change to blue. A concave polygon is a polygon that is not convex. Okay, well that's easy enough. So let's do this. Here is a concave. If I extend this line, I'm okay. But once I extend this line, you see how this one's going inside? And you see how this one's going inside? So it's inside the cave. Okay, it is concave. Okay, if they call something an n-gon, okay, that's kind of a weird, little bit of a weird name. So an n-gon is the number of a polygon's sides. Okay, equilateral. Equi means equal. All sides are congruent. equiangular, all angles in the interior of a polygon are congruent. Regular, super special, super special. Regular or convex, so they have to be convex, polygon that is both equilateral and equiangular. Okay, this is hugely important. Okay, so let's talk about one of them. If I tell you that all the sides of a triangle are equal, and then all the angles are equal, that is a regular triangle. So now we're talking about shapes. Okay, let's go on to define some more shapes because there are some special words that we need to know. So that's on the next page. Okay, if a polygon has 3 sides, it is called a triangle. Tri means 3. If a polygon has 4 sides, it is called a quad, which means 4, quadrilateral. If a polygon has 5 sides, it's called a pentagon. Okay, our US pentagon has 5 sides. If a polygon has 6 sides, it is called a hexagon, and hex means 6. 7 sides is called a heptagon. Hepta means 7. 8 sides is called an octagon, like a stop sign is an octagon. 9 sides, so octo means 8, like octopus, 8 arms. 9 sides is a nonagon. Non means 9. 10 sides is a decagon. Dec means 10, just like with the word decimal. 12 sides is a do. Do means 2. Dec means 10, so 2 plus 10 is 12. Agon. And anything greater than 12, we're just going to call an n-gon. Okay, you need to memorize this. Okay, let's keep going on the notes. Okay, example 1. They're asking us to identify polygons. So if we're going to identify polygons, we have to remember what they are. So a polygon is a multi-sided figure that's closed. So if you were a mouse, you couldn't get out, and you don't have any endpoints inside. So each side intersects exactly 2 sides, one at each endpoint. Okay, because of this is inside, this is not a polygon. Because of the curve, this is not a polygon. The other 2 are polygons. Now, remember, concave and convex are the 2 names we want to figure out. So, convex, if I extend the lines of my polygon, they never go inside. If they don't go inside, that is convex. If I extend the sides and they go inside, there I am. I'm inside right away. I'm inside. Because I'm going inside, I'm going in, just like going in a cave, that is concave. Okay, that's your example 1. So we identified two shapes that were not polygons, and then we identified a convex and a concave. Okay, so let's look at the next example. This one asks us to classify. So classify polygons by the number of sides. Okay, tell whether the polygon is equilateral. So what is equilateral? Means it has all equal sides. Equiangular, equal angles, or regular. Regular has both equal sides and equal angles. Okay, regular is not regular. Regular is super special. You've got to always remember that. Okay, look at the first shape for A. I see I have 1, 2, 3, 4, 5, 6 sides. It's a closed shape. That's a hexagon. All right, then I look and I see, wait a second, all the sides are equal. They have the same hash mark, and all the angles inside are equal because they have the same semicircle mark. So this is a super special hexagon. It's a regular hexagon. Okay, changing colors. Okay, look at the next shape. The next shape has 4 sides. It's a closed figure. Closed figure with 4 sides is a quadrilateral. Okay, are its angles all equal? What do you think? I have these singles. Those two are equal, but then these two are doubles, so they're not equal. So far my angles are not equal, so it's definitely not equiangular. Now look at the sides. So when we do the sides, look what I'm seeing. These are equal because they have the same number of hash marks, but these are not. So the sides are not equal either. So it's just a quadrilateral. Okay, next one. Let's look and see what we have. I see I have a closed figure. I know that's concave, but they didn't ask me that. So let's figure out how many sides I have. So I think, let's see, I think we can count them. Let me just change my color. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So I have 12 sides. So it's a dodecagon. And I see I have a lot of right angles inside. But let me think about this for a second. If I'm going to classify it as being regular, what's my requirement? Let me go back one more. To be regular, it has to be convex. Because this one is concave, so this guy is concave, it cannot be regular. So what does it have? It has the same, it's equilateral, isn't it? So it's equilateral. And what else is it? I see I have right angles lots of places, but look, this inside one is not 90 degrees. So it's only equilateral. And I'm putting concave in parens because the fact that it's concave tells me it could not have been regular. Okay? I have equal sides. I don't have equal angles because some of the interior ones are actually obtuse because they're greater than 90 degrees. Actually, they're even greater than that. So, bottom line, this is a dodecagon that is equilateral, and that's all you would state about that. Let's go on to the next page. There's one more example here. So this says, example 3, a table is shaped like a regular hexagon. So hexagon is 6 sides. Regular, it means equal sides, equal angles. Okay, so just these two words give a lot of information. The expressions shown represent side lengths of the hexagonal table. Find the length of a side. So, if the sides are going to be equal, I can set the sides equal with an equal sign between the two expressions, correct? Now your job is to get the x's on one side and the numbers on the other. Subtract 3x, subtract 3x. I now have 6 equals 1x minus 2. Add 2, add 2. I have 8 equals x. So, therefore, I now know what x is. Have I answered the question? Find the length of the side. No, I have not. So now let's use our x. So when the side was 3x plus 6, and x is 8, 3 times 8 is 24, plus 6 equals 30. That, and it's going to be inches. That's the length of a side. Now, what would be a really good idea is make sure the other one is 30 also, because it has to be regular. So 4 times 8 minus 2. 4 times 8 is 32, minus 2 equals 30. That checks. So the side lengths are 30 inches, and I got that by setting them equal, and I knew I could do that because I knew it was a regular shape. Regular shape, remember, means that the angles and the sides are all equal. So if I was going to mark this up, I could have said, put single hash marks everywhere. That tells me the angles are all, the sides are all the same. If you want to then express the fact that the angles are all the same, go ahead and put the same shape by the angle. Those angles are now all the same. Given the two things, I can say the shape is regular. Since it is six-sided, I can say it's a hexagon. And is it indeed convex? It is, because if I were to extend these sides, they would never pass inside. So it can be called regular. Okay, let's go to the very last page here. Here is some extra practice, and actually it's not quite the last. So tell whether each figure is a polygon, and if it is, tell whether it is convex or concave. Okay, both are polygons because they are multi-sided figures, and the sides do not pass inside. So they're both polygons. This first one is going to be convex. This next one is going to be concave. How do I know that? If I take a side and extend it, it's going to go inside. Once it goes inside, it goes in the cave, it is concave. Okay, go to the next one. Classify the polygon by the number of sides. So that's one question. Tell whether the polygon is equilateral, equiangular, or regular, and explain. So you've got 3 different things to do here. Okay, the first one. Classify the polygon by the number of sides. So we'll call this A. So for A, this has 3 sides. It is a triangle. Now you have to memorize these names. Tell whether the polygon is equilateral, equiangular, or regular. What do you think? If 2 angles are the same, let's think about this. If 2 angles are the same, do I have to have 3 the same? No. And if 2 sides are the same, does that mean that 3 are the same? No. So it is nothing. I can't say anything here. It's not equilateral, it's not equiangular, and it's not regular. So I'm just going to say no, or none. Explain your reasoning. Okay, so sides are not equal, angles are not equal. That's my reasoning. Let's go to the next one. A, number of sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides is an octagon. Again, you've got to memorize these. Okay, what do I see? Sides are equal because they all have one hash mark, and angles are equal. So that really is my reasoning. So let me now put that there. Since I noticed that, I can say that it's regular. And why can I say that? Because the sides are equal and the angles are equal. All right, last one. This has 4 sides. If it has 4 sides, it is a quadrilateral. And you want to memorize that as well. So what do I see? I see I have the same hash mark on the sides, but I have different hash marks on the angles. Some are single, some are double. So I can say that it is equilateral. Okay, what's my reasoning? Sides are equal. Okay, one more problem. Here we go. What does this say? So I think oh, there it goes. That's better. So let me just erase what I just had. Okay. A rack for billiard balls is shaped like an equilateral, so that means equal sides, triangle. Find the length of a side. Okay, so if I'm going to mark this, every side is equal. So you can set the sides equal to each other, solve for x, and then find the length of each side. Okay, bring over your x's to one side, rewrite your equation, bring your numbers over to one side, rewrite your equation, isolate your x. X equals 3 is important, but I am not done because the question is find the length of the side. So let's use our x. So if I know a side is 6x minus 4 and x is 3, 6 times 3 is 18 minus 4 is 14. So that could be an answer, but before I commit to that, I'm going to figure out if the other side's the same. 4x plus 2, 4 times 3 plus 2. 4 times 3 is 12, 13, 14. 14 inches, and that checks. So that is my answer. The billiard balls are in a rack which has sides of 14 inches each. So that's our lesson. And we have now ended this chapter.